So it is 10 a.m. Thank you all for waking up on a Saturday morning to listen to this great talk about new technologies and new green technologies. Um, we are having a bit of technical difficulty getting our panelist and speaker on, but I'm just going to introduce the speaker series and Solar Oregon in general while we figure out those difficulties. So this is our first talk of the Green Energy series, and this series was completely created and put together by a group of amazing volunteers that we have at Solar Oregon. So huge thanks to Carrie Booth, Denise Roy, Linda Barnes, and Mark D'Arienzo, and Edward Louie, of course, who will be presenting today. And so these series will continue on the first Saturday of each month at 10 a.m. and touch on a number of different topics. And the first one today is new technologies. So innovations and new things coming out in regards to clean home tech. I am Grace Hardy. I am a program manager at Solar Oregon, and Solar Oregon is a nonprofit focused on education, outreach, and advocacy to increase solar in Oregon. So as part of that, we do regular How to Go Solar Plus Storage webinars. We also have a number of events per year, including we just had our Go Zero Tour, which is a tour of zero energy homes in Oregon. And then we also have our annual Solar Winery Tour. We also organize solarized campaigns. So these are campaigns to get whole neighborhoods to go solar together. And we like to focus on peer-to-peer education. So this presentation is hopefully it's a bit beyond the scope of Solar Oregon's typical work on solar, but all energy efficiency technology supports our mission, and so we're really happy that our volunteers put this series together. We are a member-based nonprofit, so our work is made possible by the support of our members. If you are not a member already, we would encourage you to check us out. You can become a member today using this link. Also, you can follow us on social media and Eventbrite at Solar Oregon. And this will allow you to keep up to date with all of our upcoming webinars and events in the future. Throughout this webinar, we encourage you to put all questions in the Q&A box instead of the chat, and this makes it a lot easier for us to pull out questions during the Q&A section at the end of the presentation. So this Q&A box can be found on the bar at the bottom of your screen. Click on it, add your question, and we'll get to you by the end. You can still use the chat to communicate with us or communicate with fellow attendees, but put questions in the box. All right, I am going to share a quick poll, two quick polls actually. The first asks for your location, and this just helps us understand who we are reaching in these presentations. So I'll give you all a moment to fill that out. I'll give a couple more seconds. Awesome. Looks like most of you from Portland, and we have a few from the Oregon coast, Eastern Oregon, and even one international. So that's super exciting. The second question I'm going to launch is asking you how familiar you are with solar technology. We have a few more seconds for that one as well. Great. Thank you all. So without further ado, I'm going to introduce our speaker for today, Edward Louie. Edward is a long-term solar Oregon volunteer who's also a building energy efficiency research engineer at Pacific Northwest Natural Laboratory. And he's also building his own off-grid zero energy tiny house. And so, Edward, I'm going to pass it off to you for the rest of the presentation. And I will pin you so you show up on everyone's screen.
Super, Grace. Do you still want to retain control over the slides? I think that might be best.
Yes, I will do that.
Super. Okay, thanks for the introduction, Grace. You guys all can hear me well? Yeah? You guys all hear me?
I think so. The participants can't respond, but if anyone is having difficulty hearing Edward, please put that in the chat and we'll address that.
Okay, super. I'll assume you guys can hear me well. Yes, thank you everybody for your attendance. Yeah, so in this presentation, I'll go over a number of new technologies and improvements to existing technologies that you may not be aware of. So with that, let's get started. Next slide, please. So as a general disclaimer, I'm presenting this presentation representing myself. So as a result, the views of this presentation do not necessarily reflect the views of Pacific Northwest National Laboratory, the U.S. Department of Energy, or Solar Oregon. And I've made best efforts to convey the facts and information accurately. However, you're encouraged to do your own research. Next slide. And so here's an overview of the new technologies. We're going to cover them kind of in the order of the price range of the technologies, in the order of being the lowest cost to some of the higher cost. I've inserted a little bit of a break in the bullets where I think, like, perhaps the delineation between, like, technologies that, most people should be able to afford to do, to ones that, you might have to budget for. Next slide. So I'm sure everybody here has heard of LED light bulbs. I'm sure you all have some LED light bulbs. If you don't, please go get some. They are incredibly affordable now. Some of the lowest cost bulbs are about $1 a bulb, and so they are just their payback periods are in the order of less than a month, and their performance is great. But in terms of new technologies that you may not be aware of, is that LED lights, despite having been on the market for well over a decade, there's some things that have changed. The LED industry has not sat stagnant. One thing that has improved greatly is the color quality of the lights. They are now improving the phosphorus in the LEDs continuously, and so we're getting higher and higher color rendition index. And a color rendition index is a measure of light quality, i.e. how accurately and well that the lights generate from the LED can produce and accurately reproduce the colors on the color spectrum. And so the higher the value, it goes from 0 to 100, with 100 being perfect. It's very common now to be able to find LEDs that are well above a 90% color rendition index. Another cool thing is that LEDs now there are now commonly available LEDs that are above 100-watt equivalent, whereas in previous years those were hard to find. Now they're much easier to find. The efficiency, which is measured by the amount of light that it can produce per watt of energy use, is continuously inching up and up. There's a little figure in the lower left corner to show that slow year-by-year inching up of the efficiency per watt. And then also in years past, LEDs that have smart features such as Bluetooth, color shifting, RGB, or in this case, programmable sunrise to sunset simulation. Those bulbs were, quite expensive, 20, 30 or more dollars per bulb. And that has fallen to the point that you can get smart bulbs for less than $10 a bulb. As well as that same price decrease also applies to LEDs with specialty shapes, such as the ones that you would normally put in like recessed light sockets and stuff. Next slide. So another cool technology that has improved and become much more available and is induction cooking. So in years past, this induction cooktops were a technology that you could find in high-end appliance stores, or you can find them online in only single burner, 120 volt single burner portable cooktops. But recently, they have become much more mainstream. So you can now find them at your, favorite Home Depot, Lowe's, Best Buy, and the price of ranges with induction cooktops has also dropped significantly. In the past, you'd be hard pressed to find one unless you spent over $2,000. But now you can find induction ranges and cooktops well below that, with cooktops with multi-burner being even less than $1,000. The cool thing about induction is that they are much more efficient. In this case, when compared to gas, they're about double the efficiency. But the other thing is that they don't produce as much indoor air pollution. And so this indoor air pollution improvement is huge. In every metric that you can measure, one metric that is interesting is a metric called ultrafine particulates. And so these are particulates that are around like 1 micron in size. They're called ultrafine particulates because they're so fine that the hairs in your airway of your nose and your lung cannot filter them, so they go deep into your lung and they get lodged into your lung, and they stay there. So that's why we keep track of ultrafine particulates and measure them and as a metric for indoor air pollution. And induction cooking results in a 90% decrease in these ultrafine particulates from cooking. And so, that was the main motivation for me to switch my cooktop range to induction. And the other benefit that I found was that they're just so much easier to clean because the cooked surface does not get hot. It gets just a little bit hot for the area right underneath the pan, but right afterwards you can put a serving plate directly on that burner surface and transfer your food from your pots or your pan directly to the serving plate right on the burner. And you wouldn't be able to do that with gas or an electric coil like that. I've gained easily 4 or 5 square feet of counter space because the induction cooktop doesn't get hot enough to damage a cook surface. Okay, do we have questions? Should we answer questions on the fly?
Totally up to you.
Okay, yeah, let's answer some questions on the fly. There's a question about new 120 volt induction ranges. Are they equivalent to 240 volt induction stoves? No. So the 120 volt induction ranges, they will cook your food a little slower, just because they're not able to put as much power into your pan at a moment's notice as a 240 volt induction stove. But if you only have 120 volt available, then that's just what you have available. You're still going to be pretty happy with the food. I think for most people's cooking, that you would not really notice that much of a difference. But if you do like wok cooking and stuff, and you need a lot of heats to be transferred into a very large pan, then you might want to upgrade. So that's just a choice. So yeah. Okay. Next slide then. So another technology that came out a good number of years ago, there was a lot of powwow to try to get people's attention to heat pump dryers a few years ago, and then somehow the effort to bring public attention to these heat pump dryers kind of went away. I think it had the reason why the public attention to these heat pump dryers went away is because they were really expensive when they first came out. But then, despite the public media stopped putting attention to these ventless dryers, the appliance industry has not been stagnant with ventless heat pump dryers. They continue to improve the technology and reduce the price as a result. So now I want to bring attention to the ventless heat pump dryer again, because now you can get them for under $1,000. And what is unique about heat pump dryers is that they don't just save energy when it comes to drying your clothes. The ventless part is really important. And so why is that important? Because a standard dryer that has a dryer vent that is exhausting the outside, it's moving about 300 cubic feet of air out of your house, exhausting 300 cubic feet of air out of your house every minute in order to dry your clothes, in order to put that moisture out. But what that does is that's 300 cubic feet of air that your HVAC system spent a lot of energy conditioning. So like on a cold day like today, you had to warm that 300 cubic feet of air to a temperature that's comfortable for you. But your dryer just takes that 300 cubic feet of air and throws it outside. And so then where does the replacement air get? Where does the replacement air come from? Well, in most homes, that replacement air comes through the cracks in the windows, cracks through the floor, all the cracks in your house. And it's cold, unconditioned outside air that comes in to replace that air that your dryer throws outside. And then your heating system then has to work really hard to warm that air up. And so as a result, when you have a ventless dryer, you're not transferring that 300 cubic feet of air out of your house every minute. And so you're saving energy on your HVAC system on top of the heat pump technology, which is more gentle on your clothing and saves energy. And so the calculations that have been on reports is that heat pump dryers save around 50% or to about 60% of the energy compared to traditional dryer. But those reports are not doing a very good job at measuring the HVAC energy savings. And so I think that ventless heat pump dryers will actually save more than that. But we haven't yet had the budget to measure in the lab yet. So, but I think, you shouldn't wait for that data to come in to get one if your dryer is in need of replacement, or then this is a really good option. Currently, I don't know that heat pump dryers have any rebates or incentives attached to them as of today's presentation, but I think that the Inflation Reduction Act, when it rolls out, will have rebates to incentivize people to purchase ventless heat pump dryers. Next slide. And then windows. We don't always think about technology in the Windows space. I don't know why, but it's like a lot of energy efficiency programs wants to sell you a widget. And that widget may be a thermostat or a heat pump, but it seems like Windows get forgotten. But I want to bring attention to them because if you have single pane windows or windows with metal frames, or just really old double pane windows, you're losing a lot of heat out of your building envelope, which is like a building envelope is your walls, your floor, and your roof, the box of your house. And in a typical kind of existing home that's 15 years or older, the windows can be over 50% of the heat loss in a home. So it's very significant, even though windows don't represent a huge percentage of that envelope surface area, but it could easily be 50% of the heat loss. And so if you can increase the efficiency of the windows, you end up saving a lot of energy. You may have experienced, getting quotes from people coming to your house to give you a price on replacing the primary window of your house. And you might have been shocked at the price of those quotes, because replacing the primary window of your house is a big project. But you can get a good percentage of the savings you would get from replacing the primary window by installing Louie storm windows. And these windows, they are available in both exterior storm, so they are mounted on the exterior of the house, and they're also available in interior storm windows. And these mount to the interior. And I think for most people, mounting a interior storm window is much easier to mount in an exterior window, especially if you have a multi-story house. And these are fantastically priced. We're talking about like $10 a square foot for custom-made sizes that you order from your favorite Home Depot, Lowe's box store, and they'll ship to your house. And they're fairly simple to mount. A 2-person job, you can get it done in a day, and they'll pay for themselves in about 7 years, is what we found in our research. Next slide.
Really quick, I see a question relating to Windows
Okay,
in the
super.
Q&A box.
Okay. I'm somehow not seeing this question. Can you read it to me?
Yes. What do you think of window quilts to inexpensively increase the heat performance of windows at about $500 per window? We tried this and wonder if it makes sense to implement this building wide.
Okay, and okay, now I'm seeing it, and there are even photos. Hard to say. I can't tell what is the material of these windows. Are they metal frame windows? Or are they vinyl? Well, anyways, if they're metal frame windows, then maybe they're worth it. If they're non-metal framed windows, then it may not be worth it to replace. And I caution so-called like low-cost window replacements. If you're talking $500 a window, material and labor together, that's not a lot of what's it called, dollar margins for this window company to work with. And so they may use some tricks to get the job done faster, and those tricks may result in your wall failing at some point in the future. So what I'm talking about is when you pull the primary window out of your house and stick a replacement window in, how you then like manage the connection between the wall and the window, and what's called like the waterproofing, the sealing, the flashing, the caulking, how you do all those details matters a lot. And if you end up with a window installer that doesn't do those details really well, then your window will look good and perform well for the year or two, but then like after the warranty period of their labor, it will fail at some point. And then if you don't catch that failure early on, it could be very expensive to not only replace the sheathing of your house, but also the siding and also the window. So something to be aware of. Next slide. Okay, heat pump water heaters. There's been a good amount of effort to bring public awareness to heat pump water heaters. Here in the Pacific Northwest, we have the most heat pump water heaters installed than any other part of the country. Some other parts of the country almost have an immeasurable percentage because the percentage is so small we can't measure it. But here in the Pacific Northwest, we have the most heat pump water heaters, and we're some metrics have measured that we finally crossed over into the double-digit percentages. So we're over 10%, which is fantastic. And the reason why heat pump water heaters are great is because they don't have to produce their own heat to heat your hot water. Like in this animation, as it shows, it pulls the heat out of the air and moves it into the hot water. And so that's how it gets its over 100% efficiency. So for every unit of energy you put into a heat pump water heater, it's able to deliver about 3.5 units of heat into your hot water. Whereas a gas water heater, you put in 1 unit of fuel into your gas water heater, you'll be lucky if you get 0.9 units of heat delivered to the water. And the same for electric resistance. They're only about like 90% efficient versus 350% efficient. And so there's some questions about, well, if I put this heat pump water heater in like my basement or inside a area that I condition, then wouldn't every unit of heat that goes into the hot water be a unit of heat that my heating system has to make up? And that's a really good question. Like logically, you would think, well, if it's taking a unit of heat out of the air that you're spending money to condition, then you would pay that dollar for dollar back in the HVAC system. But we did those tests at P&L's laboratory homes, and we did it in very controlled experiments, and we found that that's not true. Magically, somehow, the heat pump water heater, your HVAC system only needs to make up about like less. It's about 47% of the heat that it captures. And the reason for this is, one, is that during the summertime, it's actually helping your house, because in the summertime when you're running air conditioning, this thing is pulling heat out of the air. And so as a result, you're getting some ancillary free air conditioning. In the wintertime, you get some free dehumidification, or you get dehumidification year round if you put it in like a basement. But then in the wintertime, oftentimes these are placed in what's called like semi-conditioned space. So like, a lot of basements are semi-conditioned. And so as a result, some of that heat that the heat pump water heater is pulling out of the air is actually heat that comes from the dirt, the geothermal heat coming out of, coming through the wall of the house into that water heater area. And so as a result, that's another reason why it's not a 1-to-1 ratio in the wintertime for makeup heat. And so pricing wise, they're more expensive than electric resistance, but in a later slide, I'll show you that these things pay for themselves really fast, and then your savings is really incredible. But anyways, let's move on to the next slide. And yeah, so next slide. So one of the things that you need to keep in mind, as I said before, is that this heat pump water heater, how it works is that it needs to extract heat out of the air surrounding the water heater. And so that means you need to have an air volume surrounding your water heater. And so some placements of the water heater in existing homes don't have that. And so here's an illustration of some ways you can get around that problem. Like, let's say your water heater's inside like a closet or something. Well, you can replace that closet door with a louvered door, and then that would be the heat pump water heater will then have access to the adjacent space's air volume, which if it happens to be much larger, then the heat pump water heater will work just fine. Another way to do this is that you can duct a heat pump water heater, and by ducting it, then you can connect it to any larger space inside the house, or you can fully duct it to the outside, and then it will work well for in the Pacific Northwest, especially like west of the Willamette Valley. Ducting the outside works really well. I might caution the eastern, east of the Cascades parts of Oregon and Washington. If you duct it outside, it might get cold enough that during the entire winter, it will switch over to using its backup electric resistance elements for much of the winter. And so then you don't nearly get as much benefit for your heat pump water heater. And then another thing is, if you do duct it, it might be wise to spend, the $100 in parts to install a Y, like I've shown in the right hand side of the slide, and install these manual dampers. And that way, then if you're in the eastern part of Oregon and Washington, for example, where in the summertime you would really love to have, some of that free air conditioning because it gets so hot out there. But then in the wintertime, if you have it ducted, then you can have it ducted. So then the heat pump water heater is not pulling heat out of your ambient or semi-conditioned space and cooling it down even more when it's already cold, and maybe your heating system's already struggling to keep your house warm. But yeah, these manual dampeners can, and it's between the intake and the exhaust. You're talking about like maybe $100 in parts. And then you can make yourself this feature of being able to fully duct to the outside, and then during the season you like it to be able to provide free air conditioning. You can have it basically be extracting heat from the inside. So that's an idea that you can do if you're ducting. But yeah, so this slide gives you all these kind of examples of how you can set up a heat pump water heater if you don't have it just sitting in an area that has access to an air volume, but rather you have to figure out how to get it to use the air volume of adjacent spaces. Okay, next slide.
Quickly, we have another question from Oli.
Okay.
What about heat pump space combined with heat pump water heating? Seems like the heat would be double pumped, but still makes sense.
Yeah, so if you have your space conditioning, your be done by a heat pump, and then you install a heat pump water heater, yeah, it does seem like you're double pumping the heat, but your central or mini split heat pump is incredibly efficient at delivering heat from the outside in, and so good on you for having one of those. And then, as I said before, a heat pump water heater surprisingly does not extract a unit of heat out of the air, and then that same unit of heat needs to be made up by your heat pump, your central heat pump, on a 1-to-1 ratio. So as a result, then it still makes sense to do this. Okay, yeah, next slide. And so, yeah, here's some quick calculation on heat pump water heater payback periods. As I said, they do cost a little bit more. Like a typical electric resistant water heater is maybe like what, $500, and a heat pump water heater is $1,200. So now you're thinking, wow, this is more than double the cost up front. What is my savings? Am I going to pay? Will this ever pay for itself? And it will, because the savings between an electric resistance water heater and a heat pump water heater is about $300 per year. So that means that it will pay itself back in 4 years or less. And then let's just say that a water heater lasts about 15 years, and so you're going to be saving thousands of dollars. And so it is a absolute home run to install one of these things. And as a result, the savings may be high enough that if you have a gas water heater that you're replacing with a heat pump water heater, and you don't have electrical service to that area where you're putting your water heater, your heat pump water heater, it may be worth the cost to hire an electrician to add a circuit and extend a wire to that area where your water heater is. Because like I said, it won't cost you $3,000 to extend that wire, and you're going to save over $3,000 over the course of the life of a water heater. And so that's pretty incredible. And so I just want to make that aware to everybody on this call. Yeah, okay. And then if you absolutely are in a weird space, like your water heater is, I don't know, in like a a bedroom closet or in an attic or in a crawl space or underneath the staircase or in a kitchen cabinet or something, and you really don't have any air volume and you really have no good way of ducting it, or you just the height of the space, for example, if it's underneath the staircase, it's just like, not tall enough for a typical heat pump water heater like the ones I showed in previous slides. This Sanco company makes a heat pump water heater that has an outdoor unit, that then they have a circulation pump that then circulates a closed loop. No, actually, this one's not closed loop, it's open loop. But anyways, it takes cold water out of the bottom of the tank and pumps it through the heat exchanger of that outdoor heat pump, and then delivers the water to the top of the tank at 120, 130. It can even do 160-degree water. This system it has that capability. And it can do this even if the outdoor air is minus 25 degrees Fahrenheit. So it's a really incredible system, and it really does increase the flexibility of the placements of being able to implement a heat pump water heater in these kind of weird spaces, such as underneath a staircase, for example. The only thing that you need to keep in mind is that they're pretty expensive. These units are over $5,000 in just parts only. So by the time you get installed, it might be 6 or 7,000. And so the payback period is much longer, but it will pay for itself. And hopefully with more competition in the future, more different manufacturers making a similar competing product, this style of heat pump water heater, the price will come down significantly. Okay, and then I have a question: how big is the Rheem unit? So all these packaged heat pump water heaters, whether it be a Rheem or an A.O. Smith, they're exactly the same size as an electric resistant water heater, but height wise, you just need to add about 16 inches. So I think if you have an existing electric resistant water heater, think it's exactly that size, and then you add another like 16 or 18 inches, and that is the size of that Rheem or A.O. Smith unit. Okay. I think that's all the questions. Okay, so cold climate heat pumps. So this area has made significant technological strides since even 15 or more years ago. I still keep hearing stories that, oh my goodness, heat pump, if you install a heat pump, they don't work when it's below 35 or below 40 degrees. And as a result, whenever it drops below 40 degrees or 35 degrees, it switches over to electric resistance, mode. And then your electric bill then becomes several $100s. And as a result, heat pumps just aren't very good. And those claims may have been true if you have a heat pump that's over 20 years old, but it's certainly not true today. We have heat pumps that can perform down to -5 or -13 degrees, and almost every manufacturer makes them. And because they can work down to -5 or -13 in the Pacific Northwest, that means they basically never need backup resistance heat ever. And you can install them without any backup resistance heat, and that also saves you several $100s during the install. And there's even many products that are rated to provide 100% of its rated heat down to 5 Fahrenheit. And so, it doesn't even start reducing its heat output until the temperatures outdoor temperatures drop below 5 Fahrenheit. So those are very good performances. And so where do you find specific make and models that can meet these performance specs? And so I've included 2 links. You have the NEAT link, and then Energy Trust of Oregon also has a product list for cold climate heat pumps that meet these performance specs. And so if you pick one out of those lists, then you will get a heat pump that can go all the way down to 100% heat to at 5 Fahrenheit and can keep working into the negative Fahrenheits. And then that means in the Pacific Northwest, you'll be well taken care of, even on the extreme days of the year. But one of the, I guess, most important things is that if you do get one of these heat pumps, is to have your contractor check the quality of your ducts in your home. If you and that's really important because, as I said early in this presentation, everybody wants to sell you a widget, and a heat pump is also a widget they would love to sell you. But when they install this widget into ducts, then how well this widget works depends on how well your ducts are in your house. And so if your ducts don't provide sufficient airflow, if you cannot move sufficient air through those ducts, then your heat pump just won't work very well. And the same thing if your ducts are very leaky, or they're just not insulated. If they're outside a conditioned envelope and they're not insulated, your heat pump will not perform well. And then you can't blame your heat pump, and you can't go back to the manufacturer and say, hey, well, this thing it's supposed to, you claim it's supposed to keep me comfortable even on the extreme days of the year, but I'm not comfortable. So what's going on? Well, they'll come back and tell you that, it's probably your ducts, and they'll be right. So yeah, that's very important that when you install and upgrade your heating system, to also check and potentially upgrade the ducts as well. And the price of one of these units, like I said, this is now, we're now entering the area of new technology where you might have to budget for the investment to be able to do this upgrade, because a new cold climate heat pump is going to be around $5,000 to $6,000 material only, and so then you add on the cost of labor to install it. But even currently, before the Inflation Reduction Act rebates kick in, there are some pretty good rebates from both the federal tax credit for this year, and then also Energy Trust of Oregon has some pretty good rebates, especially if you are replacing a electric forced air unit with a cold climate heat pump. Okay, next slide. Okay, so we're talking about ducts. Okay, well, what happens if you have really bad ducts and they're in a location where it's going to be a royal pain to upgrade those ducts, or it's just simply not feasible? Well, in that case, you can upgrade to a ductless heat pump. And these ductless heat pumps that can perform down to 5 Fahrenheit and into the negative Fahrenheits, they've been around for like 15 years. So these are definitely not new products. But what is new is that they are continuously improving a metric called turn down ratio, and how well they perform in terms of energy efficiency at these turn down ratios. And so what I mean by that is, let's say you buy a 12,000 BTU or 1 ton ductless heat pump. Well, in the moderate temperature days of the year, that heat pump does not need to output 1 ton of heat or cooling in order to satisfy the heating and cooling needs of that space that it's supposed to condition. And so what these ductless heat pumps can do is they can turn down, and turn down, i.e. like slow down this fan, slow down the compressor, and save energy as a result of slowing down the compressor and slowing down the fan. And so that way the heat output or the cooling output is matching the cooling needs and the heating needs of that space. And so then you're not getting blasted with heat or blasted with cold air, and then having those comfort issues. And so when it's running at these turn down capacities, how much energy is it drawing? That in the past has been still kind of high. And so even on that, during those part load days of the year, you weren't nearly getting as much energy savings as you were expecting. Whereas the more modern cold climate ductless heat pumps, that the energy savings from part load is decreasing fairly linearly with the turn down. So that's really cool. And then there are also manufacturers also making them easier to clean. And then there's now also more and more models that are called ducted mini split heads. And so later I'll have some slides to show you more of what that looks like. But there's a picture in the lower right corner of a ducted mini split, and that is cool because these ductless mini split heads, they only get so small. The smallest you can get is about a half tons or 6,000 BTUs, and you're not going to put half a ton into a bathroom or a really small bedroom. That's just way too much heating and cooling for a really small bedroom or a bathroom. So how do you provide conditioning to those small spaces? And a good way is to have a ducted solution to provide a mini split that can condition maybe like 2 bedrooms and a bathroom or something like that, so to spread that out. Next slide. And so ductless heat pumps, they come with mesh filters that you slide on top of the unit. And when you get one, you're going to be told that you need to clean them, vacuum them, clean those mesh filters with soap and water when they get gummy. And that's all good advice. That's very important maintenance. But those mesh filters, if you think that they'll ever filter the air good enough compared to like a furnace filter, one of those like pleated media filters, you would be kidding yourself. And that's why ductless mini split heads, because they have those mesh filters, there is some amount of dust that gets through them, and that dust accumulates in the coil of the ductless mini split, and it also accumulates on the blower wheel. And so after a while, you have to take apart the ductless mini split head and do a deep clean. And this deep clean is about 3 to 4 hours of work. And if you get an HVAC contractor to do it for you, they'll charge you about $300 to $400. And so that is something to keep in mind if you do get a ductless mini split heat pump with one of these wall hung style units, is that you do need a budget for a deep clean, in the long run. And this deep clean is probably needed maybe once every 2 years, once every 3 years, maybe. If you really use it in a dusty space, you might even need to deep clean it every year. But it's something to keep in mind. And that's why I mentioned in the previous slide that there are manufacturers that make units where it's easier to take apart and deep clean. And so that is a new technology in the ductless mini split head space, is manufacturers making units that are easy to deep clean. Currently, I'm only aware of actually one make and model that's really, I would consider, easy to deep clean, but I think there'll be more coming on the market. Next slide. And so if you opt for a ducted mini split, one of the cool things that has recently come onto the market is a easy zone. And so it's a zone dampener system that you mount in front of your ducted mini split, and they provide wireless thermostats to each of the zones. And so in the like it's shown in the animation, you can have a thermostat in each room, or including even bathrooms and stuff, and be able to set the temperature of each of those rooms individually. And the zone dampener will open and close and adjust the zone vane to provide the amount of heating or cooling necessary to keep that room comfortable. And that way you can condition multiple rooms to precise temperatures with one ducted mini split. And when you have one or more of these zones in off mode and it closes that dampener, this easy zone product will then talk to the fan of the ducted mini split and slow down the fan, because when you have multiple zones closed, you just don't need that many CFMs anymore of airflow, and so slow down the fan and provide you with efficiency that way. This product originally, believe it's like a French or Italian company, but they now have a US office and a US distribution, and so now it's possible to get this product in the US without having to import it. Next slide.
Edward, I think for the sake of time, maybe we answer a few questions, and then if we have leftover time, we could continue on.
Okay, sure. Are there questions that come in?
Yeah, do you have access to the Q&A box, or do you want me to read through the questions?
I have in the chat. Oh, okay. Open. I see. Open questions. All right. Are the heat pump water heaters available in compact modes rather than full height? So yeah, the Rheem and A.O. Smith, those packaged heat pump water heaters, they don't really have a compact model. As a result, as I said, if you want one that can has a tank that can fit underneath a staircase, you're going to have to go with one of those Sand CO2 models where they do make those squat short tanks. So yeah, what about heat pump combined washer dryers? Do they have a problem, or are they efficient and durable? Well, I'm getting ready to test one in my tiny house, and people have warned me that I need to be very vigilant about cleaning the units before starting a new load, because once you mix the lint and water, you end up with lint that is now turned to concrete and can potentially reduce the lifespan of those units. So yeah, I'm not sure. I think combined washer dryer is a product that you should only opt for if you absolutely need to, because you don't have the space for a stacked washer dryer. But if you have the space or can make the space, I would really recommend you have a what's it called, a stacked scenario instead of a combo unit. Not sure if you will about new solar panels, but CIGS solar has some real advantages. I'm not familiar with that acronym. Maybe later you can tell me what it is. So maybe we'll leave that one. There's also those photos are quilts installed over vinyl double pane windows available from Window Quilts. Okay, yeah, insulating shades. Insulating shades, they do work. But one thing you have to keep in mind with insulating shades is that they will not prevent the humidity from the indoor air from touching the glass of the primary window. And so what we found in the research lab is we recently did an experiment with Hunter Douglas. And what we found is that with insulating shades, whether it be insulating quilts or cellular shades, is that you end up with condensation and fogging of the window glass, because the humidity is still able to touch the glass surface, but the insulating part of the shade has reduced the heat that goes through the window, and so the interior glass surface has gotten much colder, and so you end up with condensation. So that is something you need to keep in mind. One way to mitigate that is actually to raise your shade like 2 inches, so that there's still like 2 inches of window that is exposed, and that allows enough airflow to mitigate some of that condensation by still getting most of the insulating qualities of those shades. So yeah, just something to keep in mind.
Edward, it looks like there's a raise hand feature that allows participants to talk. And the Ole Erison who asked that question raised their hands, so I'm gonna allow them
Okay,
to talk.
sure. Hello, Ole.
No, you've answered my questions. Yeah, the only one remaining was, are there heat pump models that can be combined with HRV, ERV technology for controlled ventilation, so you can reduce CO2 and stuffy air indoors?
Yes, there is a product called Middle Air. I can get you the link. We can get you the link. That's the one product that I know of that does that. Um, the thing is that Middle Air product, because it's combined with a ERV, its heating cooling capacity is not that good, and so you need to like install in kind of a small space. If you think that Middle Air will be able to replace your 3-ton heat pump, you would be mistaken. Like that thing, you might be able to replace like a 3/4 or 1-ton heat pump with the Middle Air and be able to do that combination. But if you have a heating and cooling needs that's beyond 1 ton, you might be best served with a just a split system and just install an ERV separate from your heat pump.
We have 500 square foot units, so that would work fine.
Oh, perfect then. Yeah. And then also keep in mind the cost. I don't know that the Middle Air is particularly cheap. I believe it's still kind of somewhere in the order of like $5,000. And so at $5,000, you might actually be able to like do, for example, like a Panasonic Spot ERV and then a mini split and come out with money left in your pocket. Yeah. Okay, so yeah, the acronym for CIGS is copper, iridium, gallium, super thin, flexible solar panels. Yeah, so I don't know that much about these solar panels. I have a slide about PERC solar panels and bifacial panels that are in the slide deck later, and I can talk about those. Have definitely been much they nowadays the cost of the PERC solar panel and the bifacial solar panel technology has made it has come down so much that there's pretty much no cost extra for those technologies, and the cost of those solar panels have come down to a phenomenal price. I have always said that solar panels is becoming dirt cheap because it's almost like the price of gotten to that price. Can we continue this next month? Sure. I mean, in the interest of time, yeah. So some of these next slides are in the solar, and so yeah, we can kind of take those slides and combine it with next month's presentation, because next month's presentation is more of a deep dive into solar, anyways. And so we can actually maybe jump to the last slide and just introduce what the topic is for the next month's speaker series.
Yeah. We have one more attendee that raised their hand. So John
Okay,
Stevens.
John, go ahead.
All right. Well, John is allowed to speak if you would like to. In the meantime, I will skip to the last slide. Yeah.
Yeah, so the next series is going to be a bit of a deep dive into solar plus storage. And as I've kind of alluded to, solar panels have become essentially dirt cheap, and storage is rapidly getting there. And so at some point, this technology is going to reach a price where the amount of energy that it can provide you over the course of its life, the price of that energy will be less than the price of buying that electricity from Pacific Power or Portland General Electric, etc. I suspect that we might even be there already in some cases, and so I'll share with you some of those findings in the December 3rd presentation.
Great. Thanks, Edward. And before you all leave, I just launched a last poll just to get feedback on this event. This is our first of a series. And so we want to make sure it's useful information for you all. and we hope that you join us next month. If you are on the newsletter, we'll be sending out the link there, and it will also be on our Eventbrite at Solar Oregon. Gonna wait a few more seconds. Make sure everyone filled out the poll that wants to. Great. Edward, do you have the link to the ERV heat pump that you mentioned?
Yep, getting it right now.
Great.
I'll put it in the chat. Okay, there it is in the chat. And then maybe I can also type an answer in the Q&A as well. Yes. Yep, and I know for a fact that this minnow air is available from different suppliers in the Pacific Northwest, because I've seen different like net zero tour homes have them.
Awesome. Well, that wraps up the presentation for today. Thanks so much, Edward, for all that information. I'm gonna end the webinar for everyone.
Okay. Thanks, everybody.